Hi, this is Mrs. Roble. This is Chapter 10, The Mole, Part 3. I'm still here with my friend the Mole, and we're going to be looking at a couple different things. We're going to be looking at a percent composition of a compound. This is a little bit of a review. You've done this in the past and didn't realize what you were doing. Also, we're going to be looking at empirical and molecular formulas, and we're going to be looking at that from mass percent. Then we're eventually going to look at hydrate and how it relates to the name. And then lastly, formula of a hydrate. Okay, so percent composition, we've actually done this before, percent mass. So up to this point, we've looked at in a compound, what is the mass of an element based on the total mass of the compound times 100. So percent composition is just the individual masses of the elements in a compound. So if I'm looking at a specific element, notice that in the numerator, we're going to put the mass of that element in 1 mole of that compound and then divide it by the molar mass of the compound. Okay, so here's an example where you have sodium hydrogen carbonate. You find this on your shelf in your pantry. It's called baking soda. They want to know what is the percent composition of the compound. So we'll look at sodium, hydrogen, carbon, and oxygen, the mass percent of each. So you're going to take each individual mass and be careful because if there is a subscript, you need to multiply the mass of that element by the subscript. Now sodium has a 1 here along with hydrogen and carbon, so you're not going to be multiplying the individual masses by a number until you get to oxygen. So here's hydrogen, carbon, but notice oxygen, you can't just put 16 grams. You have to multiply it by 3 and you get 47.998 grams divided by the molar mass of the compound. Now if you take all of these numbers and add them up, you should get 100%. Okay, this is something new. This is called empirical formula. So empirical formula is what we call the smallest whole number ratio. So notice that it has to be a whole number ratio. And this goes back to Dalton's atomic theory. So by doing it, you can assume that there's 100 grams of a compound and you're going to convert the mass of each element to moles. So empirical formula, please remember, it is not necessarily the same as the molecular formula. So molecular formula could be totally different. For instance, molecular formula of hydrogen peroxide, so the peroxide that you find in your bathroom cabinet, that typically has a formula of H2O2. Now, if we look at the smallest whole number ratio of that, notice that the empirical formula is HO as opposed to H2O2. Okay, so molecular formula tells us what is the actual number of atoms for each element in a compound. And please note that there's no fractions with molecular formula. It's always going to have a whole number subscript. And you're also going to find that the molecular formula is a whole number multiple of an empirical formula. So for instance, propane. Propane is something that you find maybe in a gas grill. It's composed of just hydrogen and carbon. So they noted that 81.82% is carbon and then the rest is hydrogen. We're going to assume that we have a 100 gram sample and we're going to multiply the decimal of the percent by each to figure out the empirical formula. So notice that we converted 81.82 to just grams, and we're going to convert it to moles by dividing it by the molar mass of carbon. So that tells us the moles of carbon. And then obviously you're going to take the mass of hydrogen and divide it by a molar mass of hydrogen to get the moles of hydrogen. Now, to figure out what is the subscripts, you would take the moles of carbon and divide it by the moles of carbon. Now you're like, why are we doing that? Well, we're trying to figure out what the ratio is. And typically with this type of problem, you're always going to pick the one that has the least amount of moles. And it just happens to be that carbon has the least amount of moles. So that becomes the denominator for both amounts. So when we take the moles of hydrogen and we divide by the moles of carbon, notice that we get 2.647 moles of hydrogen. So we don't get a ratio of 1. We get something bigger than 2. Now, since you cannot use a fraction as a subscript, you have to multiply it by a multiple. And the best way to get rid of this 2.6 is to multiply it by 3. And you have to multiply both atoms by that factor, and this becomes C3H8. So that's how we would get a whole number for the subscript. Okay, so here's a little flow chart that I will share with you. So notice that for percent composition, you want to convert it to grams, and then you're going to multiply it by, or I'm sorry, divide it by the molar mass of each element, and you'll get some moles, and you're going to pick the smallest moles out of that grouping, and then convert it to a ratio. And once you have that ratio, if it's a whole number, you don't have to multiply it by a factor like we did with the last problem. And that will give you the empirical formula. Now, molecular formula is something a little bit different. This is the total number of atoms in a formula, just like hydrogen peroxide. You may have to double the empirical formula or triple the empirical formula, depending on what's going on. Okay, so percentage of mass of an element tells us the total mass due to that element. Please remember that subscripts have to have a whole number ratio. We can't have fractions with subscripts. And the molecular formula, it could be a multiple of the empirical formula, just like with hydrogen peroxide.